In this video, we're solving this equation, meaning that we need to find a specific x such that, when filled in, the left-hand side is exactly equal to 1. Now you might recognize this equation as being a radical equation because of the x appearing inside of the square root. However, this time we have a more advanced radical equation because we now have multiple terms containing a square root. Therefore, we will need to do a bit more work, and this is exactly how you solve them. In the first step, we're going to get rid of the fraction on the left-hand side, and we'll do so by multiplying both sides of the equation by the denominator. And this gives us the following. On the left-hand side, we simply get the enumerator, so the square root of x plus 1. And on the right-hand side, we simply get the denominator, which is the square root of x minus 1 plus the square root of x minus 2. And the next step is one that is always performed for radical equations, namely squaring both sides of the equality sign. On the left-hand side, we see that we square the square root, effectively eliminating the square root. So we simply get x plus 1. On the right-hand side, however, we see that we now have the square of a sum of two square roots. Well, we will simply calculate this and see what we will actually get. If we use our formula for a plus b squared, we get the following. We get x minus 1, which is effectively a squared. We add to this b squared, so x minus 2, but now we still have to add this 2a times b. So this simply becomes 2 times the first square root, x minus 1, multiplied by the second square root, x minus 2. Then if we bring all of the x's and constant numbers to the left-hand side of the equality sign and only leave the square roots on the right-hand side, we get the following. We get x plus 1 minus x plus 1 minus x plus 2, which is equal to 2 times the square root of x minus 1 multiplied by x minus 2. Then we can still rewrite the left-hand side. We have x minus x, which simply becomes minus x. And we have plus 1 plus 2, which of course becomes plus 4. And on the right-hand side, we simply have 2 times the square root of x minus 1 multiplied by x minus 2. And normally at this point, we are left with a simple linear or quadratic equation, which we then solve. However, here we see that we still have a square root in our equation, and thus we're again left with a radical equation. However, this of course means that we can again use the same procedure that we just did, which is exactly what we will do in step 3. We solve a radical equation by squaring both sides of the equality sign. In this case, on the left-hand side, we get x squared minus 8 times x plus 16. And on the right-hand side, we simply get 4 multiplied by whatever is inside of the square root, since taking the square of a square root eliminates the square root. So we get 4 times x minus 1 multiplied by x minus 2. And now we see that we have effectively reduced our radical equation to an equation that we're more familiar with, simply a quadratic equation. We can rewrite this as follows. On the left-hand side, we have x squared minus 8 times x plus 16. On the right-hand side, we can calculate the product of these two brackets, such that we get 4 times x squared minus 12 times x plus 8. And now, of course, we can bring all of the terms to the left-hand side of the equality sign. So we get x squared minus 8 times x plus 16 minus 4 times x squared plus 12 times x minus 8 is equal to 0. Taking together all of the equal powers of x, we have x squared minus 4 times x squared is minus 3 times x squared. We have minus 8x plus 12x, which is of course plus 4x. And for the constant terms, we have plus 16 minus 8, which is of course plus 8. And this has to be equal to 0. And we see that we've reduced our complicated looking radical equation to a simple quadratic equation, which we can now very easily solve. We know that for a quadratic equation, we have two solutions, x plus minus, which is equal to minus b, in this case minus 4, plus or minus the square root of 4 squared, so 16, minus 4 times a, which is minus 3, times c, which is in this case simply 8. And we divide this whole by 2 times a, so in this case minus 6. Computing whatever is inside of the square root, we get minus 4 plus or minus the square root of 112 divided by minus 6. Now, the square root of 112 is of course not something you immediately know. However, after some thinking, we know that 112 is equal to 16 times 7. So the square root of 112 becomes the square root of 16 times 7. Now, of course, this 16 here, because it's in the product of two numbers, can be brought outside of the square root by taking the square root of it. So we simply get minus 4 plus or minus 4 times the square root of 7 divided by minus 6. And we can, of course, divide all of these terms by minus 2, such that we eventually get that our x plus minus is equal to 2 plus or minus the square root of 7 divided by 3. And this is our final solution, which, if we didn't make any mistakes, effectively solves the following equation: the square root of x plus 1 divided by the square root of x minus 1 times the square root of x minus 2. And if we effectively fill in our solution, then we should indeed get 1. And this is how we solve a more complicated form of a radical equation. Simply apply the procedure for a normal radical equation twice. If you enjoyed this video, consider giving it a thumbs up. And if you want to see more in the future, you should of course subscribe. And with that, I thank you for watching, and I will see you in the next one. Bye.